We now have bagged some of the biggest black holes ever recorded in the history of science that have gobbled up over 20 billion stars.
If there's one unquestionable truth that appears perplexing, it's the concept of black holes. These mysterious phenomena in the universe have always eluded complete understanding, yet they have fascinated us for decades. If you're interested in observing a black hole tonight, step outside and gaze toward Sagittarius. There lies the center of a galaxy with a black hole, possibly weighing 2 to 4 million times the mass of the Sun, hidden at the heart of our cosmic neighborhood. There is a theory which suggests that the entire universe lies inside a black hole, and we live inside a black hole. Astonishingly, the recent discoveries prove this theory. Join us today as we explore the mystery of black holes and the idea that the whole universe lies inside an enormous black hole. Nothing in the universe rivals the power of a black hole. Existing as a fusion of space-time and matter condensed into a single point, they possess the ability to absorb anything that comes into contact with them. Despite our awareness of their immense power, many specifics about black holes remained elusive until now. The photograph serves as compelling evidence. The black disk at the center is the event horizon, marking the point of no return. Cross that threshold, and escape becomes impossible. Scientists have dedicated decades to studying black holes, and they finally unraveled the inner workings of one. Before delving into the recent discovery, let's establish some background. Although most of us grew up acknowledging black holes as real entities, there was a time when they were mere theoretical concepts until the first black hole, Cygnus X1, was identified in the late 1960s. This discovery provided insights into how black holes operate. For example, researchers found that a black hole is an extraordinarily dense region of spacetime with gravity so immense that nothing, not even light, can escape it. They also uncovered variations in black hole sizes, ranging from the largest at approximately 200 kilometers across to the smallest, comparable to the size of an atom. Cygnus X1 is categorized as a stellar mass black hole, only 6 times larger than our Sun, but possessing the same mass. The identification of Cygnus X1 also unveiled that black holes typically possess robust magnetic fields and wield formidable gravitational forces. This renders them highly perilous, capable of inducing substantial destruction in the universe if left unattended. This revelation empowered researchers to delve deeper into the workings of these powerful cosmic entities, enabling the formulation of theories that enhance our comprehension of these enigmatic occurrences. This breakthrough also shed light on the scarcity of black holes. Despite potentially numbering over 1 million in the Milky Way alone, detecting them remains exceptionally challenging, prompting speculation that the actual count might be significantly higher. With such a prevalence in our galaxy, the imperative arose to gain further insights into them, sparking the quest to unravel the mysteries concealed within a black hole. Essentially, when an object enters a black hole, it becomes ensnared and compressed dramatically until it reaches a singularity, the core mass point where all matter converges into a single particle. However, prior to reaching this point, traversing 2 layers of the black hole is necessary. The initial layer, termed the outer event horizon, forms a boundary encircling the mouth of each black hole. Anything going into it becomes irretrievably trapped due to the formidable gravitational pull. This layer functions by trapping and decelerating anything that enters it to the extent that escaping would demand exceeding the speed of light, a feat currently deemed impossible within our current grasp of physics. It marks the point where the principles governing our universe cease to apply, giving way to a fresh set of disorderly laws that dictate the internal proceedings. The second layer, termed the inner event horizon, serves as an entry point leading toward the singularity. The true peril emerges here, as any particle entering this layer faces slim survival odds. It is nearly certain to be compressed into a singular point of matter with no escape. Gravity wields such dominance at this stage that it warps even light itself, causing time to slow down and temperatures to reach unimaginable highs. So, not only is matter crushed, but it undergoes a scalding process. The hazard posed by black holes lies in their distinct gravitational pulls, rendering them exceptionally challenging to study and predict due to their erratic behavior. Adding to the complexity is the fact that, owing to the immensely strong gravitational forces within and around a black hole, direct observation becomes an impossibility. Scientists must rely on observing stars orbiting in proximity to these entities to extract meaningful information about their interiors. Picture it like this. There's this incredibly powerful entity in space that demands understanding, but it exists in 3 dimensions, while our study is confined to telescopes and pictures. 2 dimensions. We're unable to venture inside because, as established, once you go in, there's no return. But there's more. The challenges in studying black holes arise from a fundamental impossibility. Our inability to travel at sufficient speeds to escape their gravitational pull means scientists are essentially restricted to observing them from a distance, a daunting task considering the vast size and complexity of these phenomena. To understand them, scientists must study the radiation emitted by black holes and the surrounding dust and gas. Creating a detailed image of what's inside a black hole becomes incredibly challenging, as any probes or cameras sent into space would be instantly crushed by the event horizon upon reaching it. Adding to the complexity is the unique nature of each black hole. There's no universal model for how they form and behave. Furthermore, physicists grapple with making sense of the singularity at the center of black holes. Our current technology lacks the capability to travel fast enough to reach it, leaving us with the option to theorize about its contents. The truth remains elusive until we discover a way to surpass the constraints of space-time and achieve speeds faster than light. Compounding the difficulty, black holes are in constant flux, evolving as they absorb matter, energy, and radiation from the surrounding universe. Any data scientists collect from observing a black hole at one point in time could swiftly become outdated as the black hole undergoes ongoing transformations. Despite the danger and mystery enveloping these immense astronomical phenomena, they can still be examined and comprehended to some extent. By mapping out stars in proximity to the event horizons of black holes, scientists can remotely observe them, gaining valuable insights into their structure and behavior. This knowledge has facilitated safer space exploration and the development of theories regarding what lies beyond the event horizons of these enigmatic entities. As scientists delve into this exploration, certain theories have emerged. And well, here's where it gets intriguing. The theory posits that black holes aren't just vast voids, but could serve as gateways to other galaxies and universes. This notion is inspired by the movie Interstellar, where characters traverse a black hole in search of a new home for humanity. If this theory proves accurate, black holes might offer a pathway to faster-than-light travel. This implies the potential to navigate through them, reaching galaxies and universes beyond our own, unbound by the limitations of space and time. However, it remains a highly theoretical concept contingent on developing technology capable of surpassing the speed of light. But that's not everything. There are additional challenges to consider. For example, the gravitational pull of a black hole would ensnare any spacecraft entering it, rendering them unable to escape. Navigating through these cosmic phenomena would demand thorough research to steer clear of such catastrophic events. Moreover, the intense radiation accompanying black holes poses a potential threat to spacecraft traversing them. Furthermore, the mysteries beyond the singularity of a black hole remain unknown. However, scientists are currently developing a spacecraft with the capability to surpass the speed of light. If successful, black holes might become a primary focus of exploration. While there's ample evidence supporting the existence of holograms, as discussed earlier in the video, delving into the enigmatic realms of these energetic phenomena proves exceptionally challenging. Enrico Rinaldi took a different approach to simplify the entire concept. He aimed to revolutionize things by combining two prevalent theories about black holes, particles and gravity, collectively known as quantum matrix models. Rinaldi took it a step further, introducing a novel theoretical concept now recognized as holographic duality. This theory posits that when observing a black hole in space, it should be perceived as a hologram. The essence of this theory centers on the notion that the outer space surrounding a black hole plays a crucial role in its functionality. It's not merely a singular point where all matter compresses, but rather part of an ongoing cycle of energy. As per Rinaldi, the particles and gases present in outer space serve as the fuel driving a black hole. Essentially, when observing a black hole as a hologram, we can witness the interaction of these elements, combining to form something new. This diverges significantly from prior notions about black hole behavior. Rather than envisioning a singular point of matter compression, the consideration shifts towards a mobile black hole. The concept suggests that it continually consumes dust particles and gases from its surrounding space, thereby enhancing its power. This implies that even if a black hole moves close to a planet, it retains the ability to ingest its matter and continue growing. The implications of this novel theory are captivating, offering the potential for an improved understanding of black holes and their conduct. Unlocking the secrets within these enigmatic objects could lead to harnessing their energy for practical purposes. While the correctness of this theory remains uncertain, it introduces a more intriguing perspective on these formidable entities. Advancing technology and ongoing discoveries about black holes keep the door open to uncovering new secrets. Time will reveal the extent of the revelations, but given what we've already learned about the internal mechanisms of black holes, the journey promises to become progressively more captivating. What's your take on black holes? Share your thoughts in the comments below. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more content like this. Stay tuned for the next one.